Hello everyone, I am Syed Mushahid Hussain, and in this video we are going to discuss three lead code problems assigned by SkipQ team. Uh, so these are the problems. This is the very first problem, that is problem number 199, that is binary search tree problem, and the binary tree right side view. Okay, so this problem says, given the root of binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see recorded ordered from top to the bottom, right? So it says from top to the bottom. So that clicks one thing in our mind, which is BFS. Breadth first search. So we can apply the breadth first search in this problem while seeing ordered from top to bottom, like in layer wise. So let's understand this problem by the example. So here is example number 1, which says the root node of this tree is 1, its left child is 2, and the left child uh, don't have any uh, doesn't have any left child, but it has a right child, that is 5. And similarly, on the right side there is a 3, and 3 does not have any left child, but right child is 4. So this tree input can be like 1, 2, and 3, mean the BFS layer by layer. So 1, 2, and 3. Then 2 doesn't have any left child, so it will be null. And then right child 5, and then 3 again has null, and then left child, which is 4. Okay. So what will be the output? The output will be 1, 3, and 4 because of these right side view. So if we annotate this problem while understanding this problem, if we are here, right? If there is a person is standing here, so when it sees in this direction, right, to this tree in this direction, he can see very clearly these nodes, right? So from the top to the bottom, the nodes will be these, right? So we have to return these nodes as seeing the right view of this tree. Okay. So similarly, we have another example, which is uh, here, the example number 2, and it says if the root is 1 and its left child is null, right child is 3, right? So the right view will be 1 and 3. Okay. And if the root is empty, so we have to return empty list. Okay. So it has constraints. The number of nodes in a tree is in range to 0 to 100, while the value can be from -100 to less than equals to the node value, and less than equals to 100. Okay. So let's solve this problem. So we have already understood the problem. So I'm going to apply a breadth first search for this. So let's create a function for this breadth first search. So the function can be like public void public void, and I can name it like write view by BFS breadth first search, and we have to pick the values. So I will need uh, any list, right? So list that will be of integers, like integer. So that will be anything like I can say results, right? Results, and as we can apply the recursion approach to this problem, so we need to compare the depths, right? So there can be any depth current node, for example, and depth of this current node, right? So as we need a root node. So I will say the node is of, yes, tree node. So tree node, this can be any, for example, current, right? That would be a root node, for example. So in this body, we will firstly check if it is null, right? So if current equals to null, so simply we will return from this function, right? So if it is not null, then you have to add the value into the list. So first of all, I'm checking according to the depth. If this is a first layer, then you have to add the first value of that node, right? So if like current depth, if it is a first layer, then the current depth, the first layer, which is 0. So or we can say 1. So it will work like, yes, it will be initially 0, right? So I'm going to store the value in the results, that is a list. So if it is equals to the size of uh, this this result, so then what you have to do, results dot add the current node dot value. Okay. So this will add a value to the current node if the size is equals, and then we have to traverse. So I'm going to use the recursion into traversing the right side of the node. So right view using BFS, and I'm going to first you have to check to the right side. Okay, current dot right right is right like this. Okay, so current dot right, and yes, again results, current depth, uh, depth plus 1, right? Okay, so this can have, the right tree can have any children's on the left side, on the left nodes. So I am after this, I am going to check if it has any children at the left side. The right view using BFS, and you have to check it for the current dot left, the game results, and current depth plus one, of course. Okay, so now I'm going to call this function inside the main function. So in main function, I have to create first a list that can be of integers, and let's say results equals to new list. Integer. Okay. So now we have a list, and we will simply call the which is the function that will fill this list from these elements, which can be seen from the right side of the view of the right side view of the tree, right? And we will just uh, give it to the root node, and the list that we have, which is results, and of course the first of all I'm going to give it is 0 because the size of the list is also 0. So on the first element it will add the first one, right? And I'm going to return uh, the results. Okay, so now I'm going to run this program. Yes, it is accepting, and I'm going to submit it. Wow, it works, and it beats 94% of the submissions, and the runtime is 1. Right, so let's understand this problem, or understand this solution. The problem is also already has uh, discussed. So what I'm going to do here, my solution is going to do, like in the very first, it is here. It will pick this node, and it will check if the current node is equals to null, then return. It is not null in this case, so my uh, it will move further, and it will check if the current is 0. So initially, if I annotate here, so the depth is 0, right? Equals to 0. Depth is 0, and similarly the size is equals to 0. Size of the list is equals to 0. So it will pick this value and add it into the we can say here, if we have list, so 1 will be add here, right? So if this is an array list, so 1 will be add here, and then what will it do? It will move to the right like this. So it will check if this tree node is null. It is not null, but the depth is here 1. Now the depth is here 1. So D is 1, and size is also 1. So these are again equals. So it will add 3 here in this list. Okay. After this, it will again move to the this node, right? and into through the recursion. So it will come here, and what it will check? It will check if this is null, this is not null, right? And this is not null, so it will check that here is again the size is equals to 2, which is equals to the depth of the depth is also equals to here 2. So it will check to, because this is the first layer, this is the zero layer, this is the first layer, and this is the second layer. So 2 is equals to 2, it will add the 4 here, right? Now it will check the right side. The right side is null, and it will return to this point. And after this, it will go to this part, right? The the left side. It will check the left side of this tree, because these node can have the right side tree can have any left node, right? So it will check if this 4 has left side, no. So it will again return to this, and after this it will return to here and check there is any left node. So it's no, no, it is null, right? So it is null. It will again return to this node, right? So in this row, this has left, yes, the left side, no. In the left side, it will check if this is equals to null, no, this is not null. But here, if we see on this level, depth is d is, you can see d is equals to 1, right? But the size is 3. So it is not equals, it will again move to the right side of this, right? This and then this side. So here it will check if it is null, it is not null, but it is again the size is d equals to 2 here. So d 2 is not equals to 3. So it will not add this value, and it check the right side and then left side and then return to the 2, and check if it is check this left side of this 2, it is again null. So it will return to the first one and terminate this function. So the final output will be this list here, right? So actually this was the problem that is traversing by BFS, this problem. So the BFS is the very good approach and solution for this problem. So now move towards the second function, the second problem, right? So the second problem is here. Okay, this is the problem number 129, which says the sum to the root to leaf numbers, right? So sum mean we have to find the sum from the root to the leaf, right? So you are given a root of a binary tree containing digits from 0 to 9 only. Each root to leaf path is in the tree represent a number. Okay. For example, root to leaf path is 1, then 2, and then 3, so it will represent 123. Okay. And return the sum of all root to leaf numbers. Test cases are generated so that the answer will fit in 32-bit integer. Okay. Okay. A leaf node is a node with no children. Any node that hasn't any children's, so that can be called that will be called a leaf node, right? So for example, we have this tree. The one is the root node. Let's annotate it. So this is the root node, and this is the left one, and this is the right one. Okay. So what we have to do, we have to traverse in this array. So if we are going to from root to the leaf node, so it's mean here we are going to the check the depth of the tree, right? So maybe I can apply in this DFS, which is depth first search, right? So the root is here, 1, 2, and 3. One is the root, two is left child, and three is right child. Mean root, left, right. And the output is 25. How? There is the explanation. From root to leaf path, we will pick the left tree, left subtree first. So from 1 to 2, it's the path, right? So it's represent 1 and then 2. We have to pick this 1 and continue to this 2. Concatenate. Yes, we are going to concatenate it. Mean uh, 1 plus 2 is not the actual actual solution that the question demands. So we have to pick it as a 12. From 1 to 2, it will be a 12, right? And from 1 to 3, it will be 13. Okay, so this is kind of understanding of this problem. So from root to leaf path, this path is from 1 to 2 represent 12, and this represent 13. So 12 plus 13 equals to 25. Okay. So similarly, we have another example, that is example number 2. It says 4 and 9 is the left side and 5 is right, the left side of 9, and 1 is the right side of 9. So here we can see the three paths, right? The three paths which will be here, as we can see this path and then into this path, right? And the second path will be this path and then into this path, right? And the third one will be this path. Okay, so let's understand this problem through annotation. So I'm going to annotate. So the first part will be this and this. So it will be 4. Yes, here we have already, right? We have. So the part will be here from this to this will be 4, 9, and 5, right? And then this path we are having a 4, 9, and 1, right? And similarly for this part we have 4 and 0. So 495 plus 491 plus 40 equals to 10, 20, 10 and 26, mean 1026, right? Okay, so actually we have understood this problem. So now I'm going to solve this problem using applying the depth first search, that is DFS. So yes, simply I can create first of all the DFS function that will return an integer. So let's say it's a DFS, right? It's DFS. So that first search is the function here, and what I'm going to do, I'm going to give it a root node that can be, for example, current in here, and I have to return the sum. for this problem, right? So first of all, again, I'm going to check if the current node is equals to null. And what you have to do, you have to simply return 0. We need not to return any value here. So the first one will be if the current node is null, then we have to return simply null. And after that, if it is not null, so what we have to do, we have to sum the number, right? Sum equals to sum multiply, because we have to overall pick the number. We cannot just sum the numbers, but we have to pick it in tens, right? So in tens, we just simply multiply the sum with the 10 and then plus the current value of the node. Wow. Okay. After this, I'm going to check if current dot left, okay, is equals to null, and then current dot right is also null, right? Then what you have to do? You have to return the sum. Meaning if we are traversed all over the tree, then you have to simply just return sum. Okay. If not this case, right, then we have to apply the recursion, which is the DFS, and we are going to return the sum. So I am going to return first of all the left tree, the sum of the left tree dot left comma sum, and with summation of DFS of the right subtree, current dot right sum. Okay, so let's call this program inside this function inside the, our main function, right? So I just simply I can return the sum, right? Sum of this root node. So I'm going to return DFS of root I have given, right? Root comma. I simply just I can create an integer here, or I'm just giving the sum as a 0, right? Okay, let's run this program. So yes, it is accepted, and I'm going to submit this program. Wow, which is a wonderful solution that beats 100% of the submissions, and the runtime is here 0. So let's understand this solution too, the help of notation. So what I'm going to do in the very first, I'm going giving the root node, and I'm checking, right? So let's annotate it. So this is our root node first, right? Root node. And I'm going to check if it is null, then return 0. It is not null, it is 1, then I'm going to update the sum, which is initially 0. So 0 multiplied by 10 equals to 0, and it will plus the value. So the value is 1. So initially sum is equals to 1. Okay. And then I'm going to check if the left is null. So the first condition, in the condition, it will false for the very first. So it will not check ever, right? So it will came here. Mean if it will again applying the DFS and check the left side, right? And it will come here. Here it will check if it is null, it is not null. So what you have to do, the sum is equals to 1, and it will simply just multiply the 1 with the 10 and plus will simply multiply the 1 with the 10, so it will become 10 and plus the value which is 2, right? So the sum will become 12, right? Again it will check in the left tree, so it is null. It will return 0, and 0 plus 12 equals to 0. It's equal to 12. 12 plus 0 is equal to 12, and it will check in the right side. Right side it is again null, so 12 plus 0 again 12, and it will return to the root, right? And it will now go to the right part of this tree, right? So it will come here, and here sum is again on the root. Sum is equals to 0. Okay. Sum is equals to 0, and it will check if the current node is null. No, it is not null, right? So the sum will become 1, right? It will become 1, and it will again check the left is null. It is not null, right? Some, and again it will come here on the right side and check if this is the 3. So to 1 multiplied by 10, right? 1 multiplied by 10, it will become a 10. And after this, what it will do, it will go to the now here we have the sum equals to 10, right? And it will check if the 3 is null. It is not null, so the 10 plus 3 will equals to 13, right? So this is 13, and after 13 it will check if any left node a3 has. So there is null, so return 0 13 plus 0 13, and then right node again it's null, so the 0 plus 13 will be 13, and then it will return here. So when it return here, so the left subtree is 12 plus DFS right is 13, right? So it will return the sum of this number, which will make it 25, right? So this was actually the solution for this problem using DFS, because we have to traverse from the root to the leaf node, right? So that's mean we have to check the depth of the every part of the uh, tree, and then we are going to simply sum their tree. Okay. Um, Now move towards the third problem. This was the second one, and the solution is uh, the best solution, which beats 100% of solution. So the third question is, okay. So due to the time limit, I have also attempt this problem, and I will explain the code here, right? So what I'm going to do here, the problem says Problem number 34. Find first and last position of the element in sorted array, right? So this is the medium problem and it says give an array of integer numbers stored in non-decreasing order. Find the starting and ending position of the given target value. If target is not found in the array and then return, you have to return the start index and end index, that is -1 and -1, which is not the index of any array. So it's mean the target value is not in there. So you must write an algorithm with O of log n runtime. Okay. So O of log n, we have to check the problem or the target value in either dividing the array into parts, right or left, right? So we have to traverse by according to divide by 2. Half of the array mean the binary traversing, right? So if the number is 5, 7, 7, 8, 8, and 10, the target is 8. So we have to find 8 in this array, and the output here is index 3 and 4. So the very first index, the 8 is occurred, that is 3, and in the last index, which where 8 is occurred, is 4. Similarly, in this example number 2, 5, 7, 7, 8, 8, 10, the target is 6, 6 is not in this array. So we simply just return output is -1 and -1 as a the number is not, the target is not in this array. And similarly, if the array is empty and we have to return the target 0, so 0 is not equals to the empty, right? So again, we have to return uh, that this target is not in the array. So here are some constraints. 0 is less than equals to numbers dot length less than equals to 10 power 5. And similarly, the index can be from -9, I mean the value of the index as -10 power 9 less than equals to uh, the index number and less than equals to 10 power 9. Number is non-decreasing array. It is not decreasing array. Array mean it's in increasing form, right? Okay, so I have solved this problem and now I'm going to explain this the solution that I give it to this problem. So first of all, I'm going to apply the approach, which is finding the first index first and then the last index. And after that, I'm going to simply return the array of that indices, right? So I have created my own function which says the first occurrence of the integer. And I'm going to give it a number array and target, right? So I'm as I have to do it in of log n time. So uh, here is on the low index and then high index mean the low is like we can say the first index and high is the last index, right? And then first occurrence is equals to -1. And here while low is less than equals to high, then mid will be equals to low plus high minus low divided by 2. I mean we will find the mid of that array and we will check if the target is on the mid or not. Like we can simply pick the example of the first example. We can take the array of the first example. So here is the 0 is the low while the length of this array is 6. 6 is the length, so 6 divided by 2 will be equals to 3. So 3 will be a mid, right, the very first, right? So we will check if numbers of mid mean if the third index of this number is equals to the target. So 5 is 0, 7 is 1, again 7 is 2, and then 3. Yes, we have 8, the target in the mid index, right? So then what we have to do, first occurrence equals to mid. So we got the first occurrence and we achieve the target, that is first occurrence, and then we are going to increase the high, decrease the high, right? So high is equals to mid minus 1. So mid is 3, mid minus 1, that is 2. High will be now here on this 7, right? After that, else if this is connected to this if, right? So this will end the while loop, I mean the condition is satisfied here, and then it will return the first occurrence, right? If it is not the case, mean if it is not on the mid, then what it have to do, it will check if the target is less than the mid, mean if the target is less than, like we can pick the second example. So 6, right? 6 is not on the third index, while 6 is less than the 8, right? So it is not decreasing, so we are going to pick the pick the left side of this array. Mean these are the higher than the target, so it will not occur in the higher part, so it will occur in the lesser part, right? So we are going to update the high here, and it will go again to the while loop, and it will check low is now also the 0. So 0 plus mid is here 2, right? So 0 plus 2 divided by 2, 2 divided by 2 equals to 1, so the mid will be this 7, right? The 1, right? So again it will check it is equals to a target. No, it is not equals to a target. So the target is again less than the mid, right? So it will update the mid to and to this 7, that is here I have selected this 7, mean the index 1, right? And again it will check, yes, low is less than high, so the mid will be updated to 0, and 1 minus 0 is 1, 0 plus 1 divided by 2. Okay, so it will come to the 0 index, right? So 0 index again, it is not uh, it is not here in the 5 is greater than now. Now 5 is the target is greater than the 5, which is 6. So it will move to the else condition where low will be updated, mid plus 1, and mid is currently here on the 1. So mid plus 1, it will 7, right? So the 7 where the index is 0, 1, and 2. So low will become 2, right? So when it will become 2, the low is greater than the while this loop will be end, and the first occurrence is minus 1, so it will return minus 1, which is the first index. Similarly, the second part of this question, let's understand the last occurrence. Again, I'm going to create a 0 index, that is low and high as the length, right? And last index again is minus 1. And here I am checking for the mid. If target equals to the mid, right? So like in the first example, the target mid is here. Mm, low plus high minus low, right, divided by 2. So it will give us 3, and 3 will the last curve is equals to mid, and mid low equals to mid plus 1. So for in the very first, we are going to update the high right here, and now in the last index we are going to update the low, that is plus 1. So in the index 1, if we check for this condition, so it will not meet to the target, while target is less than the mid, which is 8, right? So mid will be -1, and again it will check in this array the left side of this array that is less than the mid. And if it will check the 5 is less than, then it will check into the greater part, right? So in greater part the while condition will become false, and it will simply return the last occurrence, which is in this case -1, right? And inside the main method I am going to call these problems, right? So which is given by this problem: search range nums and the target. So what I'm going to return new integer array, and in this array will be the first occurrence of numbers and the target, which will return in, like in second case, -1, and the last occurrence of num and target, and it will return the -1. So the array will become like this, okay, and it will simply return. And in this part it will become like this, right, in the first example. So now I'm going to run this program. Yes, it is accepted and it works properly. Now I'm going to submit it. Yes, it is a quite better solution, which beats for 5% of the submissions of the Java, and the runtime is 1. So these were the problem of LeetCode for today's demo, and I hope this will help the programmers which are going to solve this problem. So thanks. See you next time.